This is a recap for Thursday, May 20th. So we went to CAMI week 27 and talked about experimental probability today. So experimental, right there, experimental. Oops, that's not what I wanted. And so let's go up here. Experimental is the probability of an event is the number of times it occurs divided by the total number of times. So it is just collecting data and recording what happens. So let's look at an example. So Kyle rolled a number cube, which has a 1, 2, 3, 4, 5, or 6. He rolled it 60 times, and they're all recorded right here. So if we do 8 plus 12 plus 6 plus 15 plus 4 plus 15, we get 60. So he rolled a 1 8 times, and a 2 12 times, and a 3 6 times, and a 4 15 times, and a 5 4 times, and a 6 15 times. So the probability that he rolled a 6, we go to the 6 and we get this 15, and we put it right here, and then we put it over the total number of times, and that can be simplified to 1/4. So the experimental probability of Kyle rolling a 6 was 1/4. That beat the odds because the theoretical, here's the theoretical probability of rolling a 6 is 1 out of 6. 1/4 is better. So what we talked about in class is that here's the data from round 1, his first 60. This could have been his next 60, and then he could have done another 60 and another 60 and kept going for weeks or months or years, and the average of these would average out getting closer and closer to 10 for each one of these, because that's what we expect. We expect 10 out of 60, or 1 out of 6. And then we went down a little ways, and we did problem number 14. Mark and Abby played a game requiring flipping a coin. Mark won when the coin landed heads, and Abby won when the coin landed tails. So let me erase this a little bit. So Mark won 10 times, Abby won 15 times. So the theoretical probability, the experimental probability of Mark winning was these 10 times right there out of the 25. So we add those together to get 25. And that's how we get this. And then simplify that to 2/5. The experimental probability of Abby winning was the rest of the times, 15 out of 25, which is 3/5. Find the theoretical probability Mark will get a win on the next flip of the coin is kind of a trick question, because we could just do this. It doesn't matter if it's which flip it is. We could just say, what's the theoretical probability that he will win? It doesn't matter that this occurred. So experimental has no effect on theoretical. So theoretical does not depend on any action. Okay, and then what I'd like to do is go over the answer key for the 5 questions that we did today. So here's the first one, and so I'll pull up my pen so I can write on the top of this. So the bar graph shows the result of spinning the spinner 30 times. Find the experimental probability of the event. So we know it's going to be out of 30 because that's the total. And this right here says that the 1 occurred 5 times. That can simplify to 1/6. 5 goes in there once, 5 goes into 36 times. So a 1/6 chance. That's why we got C. Many people chose on this the 1 out of 5 chance, because they read that 5 and then they put it right into the fraction. Next question. So if a beanbag is tossed randomly on the square below, what's the probability of green or red? So there's 1, 2, 3, 4, 5, 6, 7. 7 winners and 16 altogether. If I do 7 divided by 16, that's going to equal 0.4375 or 43.75%. That was B right there. Third question today. So the probability that Luis will fail his statistics is 0.23 or 0.32. What is the probability he will pass? So we need to come up with a number that will add up to 1. So that is 0.68. 32% plus 68% is equal to 100%. So we can do it as decimals, or we can do it as a percent. Fourth question is similar. It says, what if the probability of rain tomorrow is 65%? What is the probability it will not rain? So it's either going to rain or it's not going to rain, and that all has to add up to 100%. So this is 35%, which is 0.35 or 35 hundredths. D. And the last question that we did today, a bag contains 15 balls numbered 1 through 15. I've been encouraging students to write things down. What is the probability of selecting a ball that is odd and divisible by 5? So 5 is divisible by 5 because 5 divided by 5 is 1. 10 is divisible by 5 because 10 divided by 5 is 2. 15 is divisible by 5 because 15 divided by 5 is 3. 12 is not divisible by 5 because 12 divided by 5 does not come out to an integer answer. It has a fraction. So anything that has a fraction is going to be in the quotient is not going to be divisible. In the other direction, we're looking for multiples of 5. So we could think of this as multiples of 5. But it has to be odd, and 10 is not odd. So that's where we get the 2 out of the 15. And that is a recap for Thursday, May 20th.